All right. What's happening, everybody? This is a 15-minute video where I am going to make some connections on systems of equations. And then I'm going to, at some point in the video, not going to tell you when, I'm going to reveal my Mount Rushmore of music albums of all time, my favorite 4. And let me make sure that's not, okay, it doesn't show my tabs, otherwise you would have seen the answers already. All right, let's talk systems of equations though. This is important. This is a great unit. You see it on the ACT all the time. It's very real world applicable, which I might do a word problem to cap this video off. But let me just first remind you what a system is. A system of equations is, it's where multiple equations kind of work together. They're related, and the solution, what I've been telling you, and I haven't been lying, but what I've been telling you is that the solution to a system is the point of intersection, the point that they share. And that's actually true if it's this type of solution. Look on the screen. This is one of my favorite websites, mathisfun.com. The middle one is what we've been dealing with so far. If lines intersect, they have one solution. It's staring us in the face. But what if they're parallel and they never touch? That could happen, right? We did this the other day. Like, parallel lines have the same slopes. What if I did y equals 2x minus 2, and then I did y equals 2x plus 4, and I said solve that system of equations? You would never be able to solve it. They don't touch. There is no point of intersection. And so sometimes there's no solution if they are parallel. Most of the time there's one solution, but also there could be infinite solutions. What if it's the same line and they're literally on top of one another? That would mean that every single point is shared, which means there are an infinite number of solutions. What's an example of the same line? If I did, like, let me do this same line but in standard form, what would that be? Would be 4y minus 2x. No. 4y minus 8x equals negative 4? No, that's just off. Let me see. I need to get a 2, so I'm dividing. I need to be an 8. There it is. So see how those two lines, they look different. Like, those look completely different, but they're actually the same line. Notice the red and the blue overlap right there. So there's an infinite amount of solutions. Okay, so that's the first learning point that I wanted you to have, is that most of the time there's one solution, but there could be none and there could be infinity. So how do we find them? We talked about 3 ways that we find systems. The first method is graphing. And I'm actually not going to focus on that much because we've been graphing a lot. And so I am hoping that you would know if we had some solution that was maybe really steep and then one that was just barely negative, that you would be able to see that the solution to this system is right there. Okay, this is the point of intersection. It's also your solution. It is also your solution. And it's an x comma y. It's a coordinate. It's a point. Okay, but let's talk again about the other 2. I want to talk about substitution for a second. Substitution. And let's pull off a good substitution problem. Substitution method, CUDA software. This is a good website for quick problems. Okay. Let's do this one. Let's do this one right here. I'll do it right on that sheet, full screen. Okay, so we have a system. This is equation number 1. This is equation number 2. They're going to work together, and there is either 1 point that satisfies both of these, or there's no points, or there's an infinite amount of points. So the way you do substitution is you look for a variable that you can isolate. So for the substitution method, we look to isolate one variable. It can be either or, x or y. I think when you see here that the best one to isolate is going to be this one because it's already by itself for the most part. So how would I isolate that y? I think I'm going to subtract 5x from this left side of the equals and subtract 5x from the right side of the equals, so that what I have as my new equation is all that's left over here is the y, and then over here now I have a negative 5x minus 13. I now isolated that y. And here's why you want to isolate a variable, is because once you have a variable isolated, you take it. Now we know what y equals, so I plug it into y for the other equation. I substitute it. And so you have to write it out and solve it. This is why we spent so long solving equations. I'm hoping you feel confident with plugging that right in there using parentheses and then doing the math. So let's rewrite this equation. We have 6x plus, instead of 6y, it's 6 times negative 5x minus 13 equals negative 6. That is our equation. This is now solvable because there's no more y's. We just can solve it for x. So 6x plus, most of your mistakes this week, class, has been on your distributive property. So be careful. 6 times negative 5x is negative 30x. 6 times negative 13 is negative 78 equals negative 6. 6 plus negative 30, 6 minus 30, that's negative 24. You can use a calculator on this subtraction. I don't want subtraction with negatives to hurt us. I want us to be able to use the calculator. Minus 78 equals negative 6. Then we add 78 to both sides, and we get negative 24x equals, that cancels. 78 minus 6 is 72. That's going to go in evenly. Let's ride. We found x. We then take x and we plug it in. I keep using red to show. We're going to plug that negative 3 in right there, because that's how we then solve for y. So 5 times negative 3 plus y equals negative 13. Negative 15 plus y equals negative 13. Add 15. See, now I'm solving for y. So all of our old techniques are coming back. Cancel. Y equals 2. So our final answer is negative 3 comma 2. That is our solution. Okay? We're at the 8-minute mark, so I need to switch over to elimination method, but just remember, with substitution, your goal for substitution is look to isolate a variable, and then you substitute your expression into the other equation, and then you solve for variable 1, and then you plug back in for variable 2. Okay, that's the substitution method. And then let's do elimination method, which is what we just did today. So I'm going to do a short one, and I'm hoping that you practiced a few. Well, we're going to practice a lot tomorrow. So let's write down. I don't want to make one up because I want it to work. So elimination method, Kuba software. Let's do this one. See what happens. Okay, we are looking to eliminate these variables. Another name for the elimination method is the addition method, because I want you to pretend whenever you see it stacked, x's, y's, numbers, I want you to draw an imaginary line almost like these are being added together. Okay? -7 and -2 would make -9, 1y and 3y would make 4, and -19 is -38. The problem with doing that, though, is that no variables canceled. So we can't just do that, unless a variable cancels. But we can't do that in this case. So what we're going to have to do, we're allowed to because we're in charge, we can pick something to multiply the top or the bottom by to see if we can get something to cancel. So when I look around, I see that this has nothing there. That kind of pulls my eye to it. So my question to you is, what do we wish was there so that these would cancel out? What number do we wish was there? The number that we wish was there is a -3. So if we choose to multiply this whole equation by -3 and we distribute it to all three pieces, our new equation will be positive 21x minus 3y equals positive 57. That is now done. We're now done with that equation, and we look to our new piece. Okay, you can rewind that if you need to. Now we do -2 plus 21 is 19. We do 3 minus 3, which cancels, and we do 57 minus 19. 57 minus 20 would be 37, but it's 19, 38. Hey, it's going to work out, 19 and 38. Love it when a plan comes together and you get x equals 2. And all you need to do now is plug it back in to go and find your y value. So, take the 2, plug it back into any of these. Let's just pick the one with the smaller numbers. Let's pick that one. See what you get. -2 times 2 plus 3y equals -19. -4 plus 3y equals -19. Add 4 to both sides. 3y equals -15. Y equals -5. So it does take a little algebra to get this. You have to be comfortable with solving equations and with graphing, and we'll also do some on the calculator tomorrow. So those are the three methods: graphing, substitution, and elimination. So I have 1 minute to go. I promised you my Mount Rushmore of albums. Remember, I've been alive for 31 years, so some of these are older, some of these are newer. But these are my favorite 4 albums of all time that I still listen to and crush today. Number 1. Saw this man in concert in high school, and I think that Continuum is John Mayer's best album. Every single track on this album is a bop. It is chill music. It is good clean the house music. It's good driving music. It's just a great album. I highly recommend that. Album number 2 on my Mount Rushmore, Only by the Night, Kings of Leon. This was my freshman year of college. Crushed this album. Saw them in concert twice in Nashville during college. Only by the Night has the famous tracks like Use Somebody and Sex on Fire, and those are just getting started, some of the best ones. Love that one. My third album, shout out to Kanye and Jay-Z, Watch the Throne. Came out when I was a teacher in North Carolina. My first years of teaching, I was a basketball coach. This was playing in the gym often. I love a lot of these songs. Know them all. And then last but not least, you know I grew up in Tennessee, right? I love me some T Swift, and Red album is her best one. I don't know about you. I'm feeling 22. I knew you were trouble when you walked in. I mean, I know all the words of these bops as well. You can find me harmonizing in the car somewhere. That's all I got. John Mayer, Kings of Leon, Kanye and Jay-Z, T Swift. See y'all tomorrow. I want to know what your Mount Rushmore of albums are. We can start off with that. Peace.